All right, this is a lecture video for arithmetic sequences, which is 14.2. I'm going to start by giving you a sequence, and then I'm going to kind of explain the features of an arithmetic sequence. So I have 6, 11, 16, 21, 26, sorry, that's bad there, 21, 26, and then dot, dot, dot. The dot, dot, dot means that the sequence continues on. If, for example, we had the 26 at the end, a dot, 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 and then another number listed with a period behind it, a single period after a number means that that's the final number in the sequence. In this case, we have the dot, dot, dot at the end here, and so it's just telling us that it's going to continue on, and so we don't know how many numbers are in the sequence. We don't know what the end of it is, but this is all that we're given. I want to remind you that the first position is a sub 1. The second term, or the second position here, which is 11, is a sub 2, the second position. The third position is a sub 3, and that's 16. A sub 4 is 21. A sub 5 is 26. And notice that the sequence position numbers also continue on until we don't have any more numbers in the sequence. The difference between what you did in the first section, which is 14.1, and what you're doing in the second one, 14.2, is that they are giving you a specific type of sequence in this one. They're telling you it's arithmetic, and they're going to tell you how to find every number in the sequence. It's not kind of a hunt and pick or trial and error type trying to figure out how to find the next number in the sequence like you did in 14.1. 14.1 really came with no rules at all. You had to sort of just figure it out. And so for this one, they're going to tell you that you're going to get something called the common difference. And common difference, well, difference meaning subtraction, and common meaning it's going to be the same all the way throughout, okay? And they're going to represent the common difference as D equals. So anytime that you're going to see an equation on your Chapter 14 online test or even in class for your final exam, the equation that has a D in it has to do with 14.2 only. It won't fit for 14.1 and it won't work for 14.3 type problems because this is the only type of sequence that has a common difference. So what does this mean? It means that you may choose any number in the sequence as a starting point other than the first number. Because for you to find the D, you would choose a number and then you would subtract the number just in front of it. And notice that I could not choose 6 and then subtract something in front of it because there is nothing in front of that number. So you may not choose the first term to start with for this. You could choose a second term and subtract the first term. So you could have chosen 11 minus 6 if you wanted to. But for some reason, I just randomly chose the third term, so I wrote 16. I subtracted the term just in front of it, which is the second term, so I wrote 11. And when I subtract the two of these, I get what? A positive 5, meaning that I could travel, oops, sorry, let me move this away. I could move all the way through this sequence and tell you every single number by adding 5. So what I like about Chapter 14 is that there's going to be a number of different ways that you can find these answers. So for example, what you know right now, you could find what the 6th or what the 7th term would be, right? You could add 5 here and find what? The next one could be 31, right? You could add 5 more and you could find that the, let's see, 1, 2, 3, 4, 5, 6, the 7th term, I just want to make sure, is 36, right? A sub 7, 7 meaning the 7th term, so the 7th term is 36. How did we do that? Well, we knew that arithmetic sequences have a common difference, and we knew that the common difference was found by choosing a term and subtracting the term just in front of it, so we found a positive 5 to be our D, or our common difference, and positive 5 means to add 5. If for some reason we subtracted this and it was a negative 5, then you would subtract 5 to find each additional number in the sequence. Okay, so that's how your common difference is found. Let's move on and look at a new example. I have negative 11, negative 4, 3, 10, 17, and 24. Dot, dot, dot means the sequence continues. In this problem, they're asking you what is the common difference of this arithmetic sequence. Well, we're going to look and we're going to choose a number. These are negative numbers. This is also a negative and positive number grouping. I'm going to move into the positive numbers. So I'm not going to use any of those that I have labeled or marked right there. I'm going to move that away and I'm going to choose this group right here. Why? Because they're two positive numbers being subtracted and that's the easiest subtraction problem I can find listed here. So I'm going to write 10 and I'm going to subtract the number just in front of it. So I have minus 3 and I get a positive 7. What did I just find? The common difference is 7. The reason that we're finding that common adding number or subtracting number, depending if this D is positive or negative, is because we are in 14.2, which is arithmetic sequences, and that's how you find each new number in the sequence by adding 7, because we did this problem, or found the common difference using choose a term and subtract the 1 in front of it. So for me to find the next term, I would add 7 more to find this term, okay? But that's not what the problem was asking us. They asked us what is the common difference. So here is our final answer. If you wanted to check this and make sure that this was an arithmetic sequence, for some reason the instructions did not tell you that it was arithmetic, you could perform the 10 minus 3 and get 7. You could also choose this right here and do 24 minus 17 and you would still get 7. You could also go back down here and you could do a negative 4 minus a negative 11. Well, two negatives make a positive, so I'm adding 11, and so this becomes a positive 7. So no matter how you perform this, any place in the sequence, you choose a term and subtract the 1 in front of it, you're still going to get the answer of D equals 7. This right here is what we call a general term. All right, so we have an arithmetic sequence, general term. A general term is an equation, okay? When the instructions say write a general term, you are writing an equation. That's all you're doing. You're not solving it for something. Now, they may ask you to solve for something, but when they say write a general term, you are writing an equation. That is important for you to remember. All right, so our first problem is a sub 1 equals negative 6. And D equals 12, they could stop right there and ask you to plug those numbers in and find an equation. But they go one step further and they want you to solve this general term or this equation for a sub 15, meaning I want to know what the 15th term is when the first term is negative 6 and my common difference is 12. So I'm going to show you two different ways to solve this. Okay, the first way is to use the equation that we have. A sub n is what I'm solving for, so I'm solving for a sub 15. I don't know what it is right now, but we're going to plug it in and find out. A sub 1 is my negative 6, plus n is 15, so I'm solving for the 15th term, and D, it was given to me, which is 12. And notice that 12 is touching that parenthesis, which means that it's going to be a multiplication problem right there. So I use the order of operations and I take care of what's inside the parentheses first. So 15 minus 1 is 14. I'm going to leave it in parentheses because that 12 and 14 are multiplied together. I multiply 12 and 14 together and I end up with, I think, 168. I'm going to subtract 6 and I end up with the 15th term equaling 162. So that's the first way that you can do this. You can plug things in. And notice that the things that were given to me that I'm plugging in are these numbers all right here. Right? The 15th term, the n came from there. I'm solving for the 15th term. The a sub 1 came from there, and the D was also, all of this blue part here was all given to me. And I just plugged it in to this equation up at the top that I gave you to begin with. Okay? The second way to solve this is a little bit more of a long process, but you're going to start with the sixth term, or the first term, which is negative 6, and then you can add 12 to that, and you can find your next term. So what would be -6 plus 12 is going to give me what? +6, right? So we're going to put 6. We are going to add another 12 and get 18. We're going to add another 12. Why are we adding 12? Because D is 12. That's my common adder. And I get 30. I'm going to add 12 and get 42. I'm going to add 12 and get 54. I'm going to add 12 and get 66. I'm going to add 12 and get 78. I'm going to add 12 and get 90. Add 12 and get 102. Add 12 and get 114. Add 12 and get 126. Add 12 and get 138. So I'm going to stop for a second and I'm going to count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I need 14, 15, and 15 is my answer. Okay. So I have 138 plus 12, I get 150. 150 plus 12 gives me 162. Notice that these two match. So you can use the equation. It's faster probably, depending on how many numbers you're solving for. Like if we were solving for the 37th term, this right side is going to take us a lot longer. But you have choices. You can use either method. You just keep increasing by 12, whatever your D is, to find your number, or you can plug them into the equation. Okay, so let's try anyone. This one, they're going to give us a sequence. This sequence is different from all the other ones because I see a ... and then I see a number 52 with a final dot after it, meaning it is done at 52. There's no more numbers. So our first number is 8, -8. Our last number is +52. I do not know what my D is yet, but what I can do is use one of two ways. I can do the same thing that I just did, which is this messy right side down here. And I can just start listing all of the numbers in the sequence that I was given. I can find out what the D is, and I can continue writing the numbers until I end up at 52, and then I can count all the numbers and see how many terms there are. Or I'm going to go use this general term that they gave us, and I'm going to plug in the things that I know, and then I'm going to solve and put 52 right there, right? Because if I plug 52 in at this point, that would be the answer that I would normally find. And if I don't know, what I don't know in this problem will be what my N is, because I don't know what term it is. So we're going to do both ways. First way I'm going to do is I'm going to see that this is 1, this is 2, 3, 4, and then I don't know. Okay? And so I'm not going to actually rewrite these first 4, but I'm just going to have them counted there. And so what I do need to find out, though, is what's happening between these numbers. So I'm going to start with 10, and I'm going to subtract the number just in front of it. So I'm going to -4, and I end up with 6. So that means that D equals 6. So I'm increasing by 6 each time. So I'm going to start with 10, and I'm going to add 6 to it, and I know that my next number is 16. I'm going to add 6 to that, and I end up with 22. I'm going to add 6 and get 28. I'm going to add 6 and get 34. I'm going to add 6 and get 40. I'm getting close now, right? Add 6 to 40, get 46. And then magically I end up with adding 6 one more time and I get to 52. So basically the 16 fits in here, right? The 16 through 46 fit in there. So if 10 is 4, that means that this is 5, 6, 7, 8, 9, 10, and 52 is my 11th term. So it's the 11 terms in the sequence, because that's what they're asking you. How many terms are in the sequence? Well, we're finding that 52 is the 11th term. That means there's 11 terms in the entire sequence. So with that being said, we are going to, not sure what I did there. All right. We're going to use the other side of the screen, and we're going to go back and use the a sub n is equal to a sub 1 plus n minus 1 times d. I know that a sub n is 52, right? It's not the term, it's the number that's actually in that term. A sub 1 is negative 8 plus n is what I don't know. I don't know how many terms there are, but I did find that d was at 6. So if I follow the order of operations, I need to simplify inside the parentheses. And I can't do that because there's an n and a number and a letter. They don't go together because they're not like terms. So I'm going to distribute this 6, and I end up with a negative 8 plus a 6n minus 6 equals that 52 on the left side. So now I'm going to put together like terms or things that match, and I end up with 52 is equal to, well, I need to add together the negative 8 and the negative 6, and I get negative 14. I bring down that plus 6 in that I haven't used. I'm going to add 14 to both sides to get numbers on one side, numbers on the other. Sorry, it's being funny over there. And I end up with 66 is equal to 6n. I'm going to divide by 6 on both sides to get n by itself, and I find n equals 11, which is nice because I already found that it's the 11th term. So you may choose to do this either way, but you're going to have to show your work on your final exam to show me what method you are choosing to use. All right, I've got 10, 5, 0, negative 5, dot, dot, dot. This problem says find the 6th term, and it says of the arithmetic sequence. So it tells you what kind of sequence. Bad handwriting. Find the 6th term of the arithmetic sequence. All right, so this is 1, 2, 3, 4, so I need 5. I actually need 6 as my final answer, but I need to have the 6th term. So easy enough, you could find out what the common difference is, and I could take 0, minus 5, and minus 5 as my d. Okay, did you see that? Choose a term, subtract the one in front of it. So that's what I got. And so I could continue this on. I could take my negative 5, and I could subtract 5, and I could get negative 10. And then I could take negative 10 minus 5, and I could get negative 15. And so I could find negative 15 to be my 6th term. Or I could use the equation, right? I could do the 6th term, so that's a sub 6, is equal to a sub 1, which is 10, and that's going to be plus the 6 minus 1 times d, and d is negative 5. Order of operations, say simplify inside the parentheses, and so I end up with 5, and I want the 5 to multiply times that negative 5, so I leave the parentheses around it. And so I'm going to multiply here and get negative 25, and then I have that plus 10. So the 6th term is equal to whatever 10 minus 25 is. So the 6th term, a sub 6, is equal to negative 15. So it doesn't matter which way you choose to do this, as long as you are applying what the d is or plugging things into the equation correctly, you should arrive at the 6th term to be negative 15 no matter how you try this. All right, the next part is asking you to find the sum. Well, the sum is the answer to adding numbers together. So it says, find the sum of the first 5 terms. Bad handwriting. Find the sum of the first 5 terms. So guess what they gave us? Not the first 5 terms, but they gave us the general term. That's 2n minus 5. So n is the position number. So if I'm finding the first term, that means that I have 2 times 1 minus 5. And if I'm finding the second number, I have 2 times 2 minus 5. And the third number is a sub 3, which is 2 times 3 minus 5. A sub 4 is n is 4, so I have 2 times 4 minus 5, and a sub 5 is 2 times 5 minus 5. Now, those are just the equations that I solve, right? I found that because they gave this to me. They told me first 5 terms. That's why I did a sub 1, 2, 3, 4, and ended with 5 because that's the first 5 terms. So I'm going to use the order of operations to solve each one of these. First thing I'm going to do is multiply and then subtract for each one of these. So I should end up with -3, -1, +1, 3, and 5. Okay, do the math. Pause it if you need to, and you can work this out. But I want to show you that if I wrote these out, that a negative and a positive cancel, and a negative and a positive cancel, so 5 is my answer. Now, if you don't like what I just did there, you could just go through and put in your calculator 3 plus a -1 plus 1 plus 3 plus 5 equals, and you're going to still get 5. So it's my final answer. It's helpful if you show your work when you're doing a paper test for your final exam to get partial credit if you miss this. But the only answer that I really need from you is 5, right? It's the sum, the answer of adding up all of the first 5 terms. All right, so let's look at a couple more examples and then we're almost done. So this is the most confusing part, because sometimes they want you just to write a general term. So before, I'm going to go back a couple of examples and remind you of what we've been doing. So we've used the general term to find out how many terms are in the sequence, and so we found 11. We also had to use the general term to plug in our a sub 1, our d, and find the 15th term, and we found the 15th term is 162. So we use the general term a lot to find how many terms are in a sequence and to find out what number is in a specific term or in a specific place in the sequence, so the 15th term. So now what we're doing is we're actually finding the equation. We're actually writing the general term. So here's what they give us. Write a general term. So if D is in this, we know it's an arithmetic sequence. So we know, because we probably have it written on our note card or somehow we've memorized it, that our general term for an arithmetic sequence, and arithmetic is what we're looking at because we see D, is a sub n is equal to a sub 1 plus parentheses n minus 1 times D. And what they gave us are these two values right here. And we're going to plug those in right here. Notice that we don't know anything else. I don't know what term I'm solving for. I don't know what number the term is that I'm trying to figure out. So we're not plugging anything else in. So the a sub n stays there. The n and the -1 are all going to have to stay in this problem. We're just going to substitute in those red pieces. So my new equation is a sub n is equal to 6 plus n minus 1 times d, and d is -2. So we're back at this place where we're going to try to simplify this as much as we can before we have a final answer. And notice that n and -1 can't go together. They're not like terms, so we're going to go ahead and distribute this. So my next line here is a sub n is equal to 6 plus, and then I have a -2, so I really could have just written minus 2n, and then it would be plus 2. So these two are whole numbers, so we're going to put those together. And so when we do that, those become 8, and then that -2n just comes down. So what I just found is the general term general term's the equation for an arithmetic sequence when the first term is 6 and the common difference is -2. So this is my answer. Okay, I had to write a general term. A general term is an equation. General term for an arithmetic sequence, because D is there, so I use this equation. I plug in the things that they gave me. These are what they gave me. And then I have to simplify this as much as I can, and I end up with an answer that is right here. Okay, let's do one more of these, and then we'll be completely done. A sub 1 equals 4, and D equals 12. They want us to write a general term. That means write an equation. So I'm going to plug it in. right? General term. I knew that I'm using this one because there's a D in it. The things I'm going to substitute out are these two pieces. So my new equation is a sub n is equal to 4 plus n minus 1 times 12. I cannot add or subtract the n and the 1, so I have to distribute to move on. And so I end up with 4, let's see, it's a positive 12, so it's plus 12n minus 12. These two are whole numbers, so we're going to put them together. And negative 12 minus 4 gives me negative 8. I bring down the plus 12n. I could write it like this, a sub n is equal to, or I could rewrite it and put them in positive 12n minus 8. I like this one better because it doesn't start with a negative number here, but they're both correct. Okay, so we wrote a general term when they give us this information.